Hello, my name is Ava Buchholz, and I'm here today to teach you about black holes. Now, what exactly is a black hole? A black hole is a region in space where lots of matter is compressed down to an infinitely dense point. This creates an incredibly strong gravitational pull. This is why anything that strays too close will be consumed, including light. Now, in order to understand them, we need to understand gravity. Gravity is one of the three dimensions of space, and Einstein, in his theory of general relativity, combined these three dimensions along with time to create what we now know as space-time. Space-time functions as a sort of cloth that covers the universe, and when I place something with a lot of mass onto this cloth, it's going to create a very large divot in the cloth. Now, when I place something with a lot less mass next to it, it's going to create a very small divot in comparison. If I place something with a lot of mass in the center, and I place something with a lot less mass next to it, it's going to circle the object with a lot more mass. This is because the object in the center of it has a much stronger gravitational pull than the smaller object, which has a lot less mass. And this is due to the larger divot that the object with more mass creates. Now let's talk about the black hole's anatomy. The singularity is predicted in Einstein's general theory of relativity. This is the point which I mentioned earlier, where all of the mass within it is compressed into the infinitely dense point. We think this is at the center of the black hole. Now, we are unable to enter one, unfortunately, so we are unsure if this is a purely mathematical place or a physical one. The accretion disk is the most well-known part of the black hole. If a star strays way too close to a black hole, the black hole will rip the gases off the star and create a very fast spinning disk around the outside of the black hole. This is due to the strong gravitational pull that is within it, but they won't enter because they're spinning far too fast. The event horizon and its shadow. The event horizon is the most dangerous part of the black hole, as after you enter it, you are unable to escape unless you can somehow break physics and go faster than the speed of light, which is impossible. Now, the shadow is due to gravitational lensing within the black hole. When you have a lot of gravity, things tend to get really wonky with how things are seen, and this is essentially a weird, warped version of the event horizon that we are seeing. This is the event horizon, and this is what the scientists call its shadow. Now, the photon sphere is this little ring of light right here, and this is, again, gravity being kind of wonky with how we're seeing things, and it's a very warped version of the accretion disk that we can see on the outside. This is actually also a very fast spinning ring of light within the center of it, but it's not actually in the center, it's actually on the outside. Now, Doppler beaming we can see in everyday life, but in a audible version. So if a siren comes closer to you, you're going to notice that it sounds higher, but when it goes further away from you, it's going to sound lower. And this is what happens with the accretion disk of a black hole. When it gets closer to us, it's going to appear a lot brighter, and when it gets further away, it's going to appear a lot darker. These are my works cited, and thank you for listening.